Where is OBS? Oh, weird. When I'm, oh no, there it is. I'm thinking like it's weird. Like Alt Tab, I can't find OBS on the window. No, it was there. I just wasn't recognizing it. I was conflating it with like Mozilla Firefox for some reason. But I'm here. Ooh, that's really small. So let's go ahead. Make you nice and big, and that way, and down there. Yeah, that works. All right, let's go ahead and open up our code. So what is it? We want to go into the workspace, and inside of here, let's take a look at our README, see what we have left to go. Right, implement the player entity plus the graphic. So slowly over time, I've been adding in all of these assets into Notion, sort of like experimenting with having Notion be an asset manager. I haven't necessarily been tagging them properly, so I've just sort of been like, first get them in here, and there's a ton of them. After that, I think I'll be able to, I guess, like find the different ones and then go with it. So there's this player character. I could choose this one. It's fairly small. We could scale it up. Like there's the archer character. I think there was like one more. I mean, there's a black and white ones that we can use. I think that player character might be the best choice. Of what I have imported right now. I know that there's other ones that I could potentially use, but I don't think I've processed them and like got them into here yet. But that will be sort of fun. So let's maybe take that first one. We'll go with the one labeled player character. So I'm gonna download that and put it, straight into, okay, so not get the streamer game. We've learned that it should go into the REST workspace, target, debug, resources. This is where it goes. So save into there. And then I'll move you off to the side, bring up these windows so I can see them again. All right, that's all good. And I should be able to see, let's see, the target, debug, resources. Here's that player character.png. All right, so we can see it. Looks like we have, we have like several different ones. It's like walking towards us, looking to the left, and looking forward. Well, that's cool. It's also like potentially a little bit unfortunate because it's not quite the same format as the other ones. So I wonder if my sprite thing will be able to handle this. Let's keep that open for right now. When we create a new sprite, yeah, we're taking in the file, how many sprites across, how many sprites down, and then it's gonna automatically loop through all of these. And I guess that's gonna be a problem for us. Also, before I forget, let's connect in Twitch chat. All right. I may have to have like a different type of sprite, like a player sprite. Or if I were to like download GIMP, I could cut this up into like the different sections. That's probably actually would be the best thing to do, would be to cut it up. So if I do if I build this out as a sprite and I just sort of set it at, tell it what it is, it's gonna loop through all of them, which is gonna look a little bit weird as we go around, but we can try it out. Bear Duda, good morning. But yeah, the player is definitely going to be a lot different than sort of like those enemy sprites. And maybe that's something that we're going to have to keep in mind, is that we want like the player sprite just has to be different. That being said, if I do that, then our game object is going to be different too. So that's also something to keep in mind. So I said good morning to you, Bear Dude, all right? If not, good morning again. I obviously haven't had my tea yet, and I went to bed a little bit late last night, so I'm in that sort of like that foggy state where I'm like, ooh, what's going on? How do I do stuff? We can close you. I don't need you open. Seems to be going around this morning. Oh, were some other people having trouble on streams? It's Wednesday also, so like halfway through the week is always, you know, that's when it gets rough. All right, so if I create a sprite from our players, let's come into our main library. You got up at 2 and didn't feel like you woke up until 5 or so. Also, waking up at 2. Like that's a thing. I try to go to bed at 10. So waking up at 2 would be a nightmare for me. Welcome to the life of a non 24. Or is it just because like I was talking to somebody on the local Denver Dev Slack, and they were telling me that their schedule with COVID is just sort of like, yeah, it's just whenever, you know, go to sleep when you feel tired, wake up when you're not feeling tired. Oh, you have a circadian rhythm disorder. Ooh, okay, that makes a lot more sense then. On top of being a night owl, so well, I feel like wouldn't one drive the other? Well, I'm sorry you have a circadian rhythm disorder, but I hope that you're able to work through that. At least like be as healthy as possible. Let's see. I want to create, so we have this create flame instruction. You made it this far, all right. Let's now create, so game objects. Let's create the player. Okay, so we're gonna need a draw system for this. Well, that needs a fire sprite down there. So before the fire, we need the fire sprite. So we need the player sprite. All right, so this is gonna be a sprite, new, context, the path. So that's gonna be slash player character.png. I don't need a label. And let's not scale it right now. What did I miss? Oh, sprite. I conflated the two. Okay, so I was not paying attention. I was just looking at up here and not here. Okay, so we have the path. What's next? The next is sprites across and sprites down. So if you take a look at this, it's 1 down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24. This is going to be fine. It's going to spin in place. It'll be great. 24, sprites down is 1. That returns a game result, so we're going to question mark that. And there we go. We have a player sprite. Interestingly, there wasn't an official diagnostic for most of your life. So basically you just had to feel like, oh, because you couldn't sleep or get up on time consistently. I have a member, I've worked with somebody, he didn't have a circadian rhythm disorder, at least as far as I knew. But he did have a something that like caused him not to be able to go to sleep or wake up on time. And so that was like very interesting, figuring out ways. It wasn't a school situation, so it's a lot different than when it's like on a normal team. School is like very, okay, well, we're kind of starting classes at this time regardless. So I hope you can make it there. I can record them, but that's about as much as I can do. All right, create this player, the player sprite. Let's create the player draw system. All right, so we're gonna create a new draw system. All right, so this it's a sum player sprite. A label, so we don't want a label, and we don't want to scale by anything. And this just returns a draw system, okay? You can often treat it with behavior therapy in most mild cases, but it just never really stuck for you despite years and years of effort. So you kind of just accept that you'll give it up and go to sleep on a drifting schedule and kind of deal with that. Is it easier to deal with that right now with the COVID stuff, with like so many other people like being at home and being remote? I would imagine that it could be. Player draw system. Once we have the draw system, they have this flame size. Oh, right, because we need that in order to give the size that we're doing here. So that player size equals, this is going to be the player draw system dot get size. Unwrap or, and let's just make it 50 by 50, because I don't really know what else to make it. Oh, and we need you to be a tuple. Okay, so now we have a player size. Let player, I guess there's the good old player. Time to create our game object. So the first thing is our X position. Where are we going to place the X? Let's just try like 250 for right now. 250.0. Our draw system. So the player draw system. Oh, which is a sum. Our width, so player size dot 0, player size dot 1. The physics system, which is a, oh, I don't have a physics system. Okay, hold on. That player physics system equal physics system new. Affected by gravity. We can say yes. Yes, true. I mean, what kind of thing is that? Okay, so that gives us a physics system. All right, so some player physics system. What's next? Live for none. The player lives forever. Oh, and that's it. And it returns the game object. So then we can throw this into the vector like that, which should just start getting drawn. So let's try and see how this looks. I need to CD into the correct directory first. You always joke about how at 6 a.m. you've either been up for a while or about to go to bed. All right. Well, that's maybe a little bit small of a player. I think that's going to be a little bit too small to watch. So let's go ahead and scale that up a little bit. So scale by maybe like, yeah, 4. Right, that's the problem. You were talking about that, which is now that we're scaling up, we need to figure out what the new width and height is. But because we're scaling by 4, we should be able to take our width and height and multiply that by this scale, right? And so if we figure out what our scale is, let's just do like 4. So player scale is 4. Put you as player scale. For our player size, so you times player scale times player scale. So if I do that, does that just work automatically for me? Yeah, it does. Okay. So I just scale up the size with the rest of the scale too. All right. So like the gravity is just working exactly right. The player falls down and stops being affected by gravity. That's perfect. So, I mean, there is this minor little problem where the player is just constantly never looking to the right, I notice. Forward, left, and backward. Do I forward, left, huh? Does this... There's no right sprite. Huh. You need to mirror the left. Oh, that's... Oh, of course, of course. I might need a like custom sprite, like logic, just for the player then. So when I'm moving left, I just use the left one. When I'm moving right, I want to use the left one, but mirror it. How do you mirror something in GGEZ? Can I do that? It's a good question. I don't know. Drop Params probably has a mirror. Drop Params seems to have everything, so I would not be surprised. You know, with a mesh or a surface, you can do a mirror flip. Oh, it's probably undrawable. If you could do it on the mesh. But I would need to do this. Okay, clear shader, default filter. I mean, so there is a transform. But I didn't say that. But let's go to like the draw params. So there's a rotation, but that will rotate like this. And so that will make it upside down if I point it to the right. So I didn't see... Flip has to be somewhere. Maybe I can just search for flip. No, mirror. Graphics wrap mode mirror. Mirror the texture like tile, but use absolute coordinate before the modulo. This is, okay, so it's an enum graph mode's wrap mode. Is this a texture? Is it a texture thing only? If it's a texture, yeah, mirror the texture. Specify how texture coordinates outside of range 0 to 1 are handled. All right. So, okay. Textures. I've played with them just a tiny little bit. Now, of course, there is another easy way that I can deal with this. I could just download GIMP and cut these up into their individual sprites. As that way I have left, mirror the left and make that a right. And then also have forward for when I'm not doing anything at all. That's probably what I want to do, is have all of those. I don't think I have any image. I have like photos. I don't think photos will do that. So I think I'm gonna have to do that off stream. Until then, let's just keep this as it is. The idea is that we'll have probably like a player standing, and that could be a sprite of just 1 and 1. And so that's this left one right here. So what happens if I tell you I want you player sprite to be sprites across is 1 and 1 down. So if I do that, oh, that's cool. I wanted to chop it up just for that one, but I got all of it. Because it assumes the size of the entire thing. Okay, so in that case, let's leave it at 24, and we'll just leave it at the weird, like, sort of turning around until I can change some things around. All right, that gives me the player. The player falls down. So, polish. This is gonna have to be like cut up the player sprites so that we have left run, right run, and stand. And then switch player to have multiple sprites based on which direction they are moving. Alright, so it gives me the entity and graphic. The player can move to the left and to the right. Alright, so what is that going to look like? Our physics engine, so we have a handle input. Right now, inside of update here, so here in update, we could get the keyboard commands. I guess technically I could try to like figure out a controller thing too. I could grab input, and so I need move left and right, I need to jump. We could just check every single frame, are we down? I think that makes the most sense because, yeah, I think that makes the most sense. If like left is down, we want to move left. If right is down, we want to be continuing to move to the right. So that's going to be something like here. So while timer, check update, we deal with these. Let's see if we can like grab the, is like the keyboard key down. So I think that's under GGEZ input. Input. So if input, let's do keyboard first, is key pressed, context, and then the key code. Okay, so we can bring those in too. Key code. Let's start with like A. Okay, so if A is pressed, then I want to be moving to the left. Moving to the left. Well, what does that really mean? I guess for right now, we'll just print line moving to the left. Save that. Rerun this. If I hit A, there, okay, we get moving to the left, and that will sort of like continuously over several frames. So that works. If I wanted to also do a controller, I haven't tried controller before. Let's try or input gamepad Oh, you don't have gamepad context, gamepad ID. Oh, this, okay, that might be a little bit, I haven't played with gamepad stuff before, so I don't know if it's not as simple as like just, hey, is like analog left down or something like that. Okay, let's go ahead and not do gamepad right this second. Maybe I'll do like a future thing to look into that. Let's just stick with A, and that moves us to the left. All right, so what does move to the left mean? We have a physics that's part of the player. So if we go to the physics system, we probably want to move to the left. So when we update, maybe it's going to be something like handle input. And then, like, I guess the input that we really care about, it's not necessarily the command, because that's the chat command. This is gonna be like the player input command, or the player movement. So maybe like player input, probably should be an enum, right? So we have like move left, move right, none. Let's do that in here. Player input.rs. Okay, so what can we do? We can move left. And I guess that's all we can do right now. And that's fine. In the physics system, we want to use super player input, and handle input takes in a player input. Which is a player input. I don't think we're necessarily going to need to return anything. We're just going to handle this right now. So if we match the player input, we're going to have player input move left. If we're going to move left, I want everything could just sort of like move by the same amount. I can just define what this is here essentially. So let's do const like move speed F32. Let's make this like 1.0 and just tweak it from there. So move left is going to be a negative move speed. So that's going to be self.velocity.x minus equals to move speed. Okay. Now, handle input is going to be something called by the game object in update. Hey, Chantilly. Now, here's the thing. We only want to call update here we only want to call update let's see, that handle input if, well, I guess, okay, here's a question. Should we separate out those physics? We've done that before, and if I do that, then it can just reach out and grab the player input itself and like handle that on its own. That might be the best thing to do. So if we do something like we have the physics system here, if I make this a trait and then we have like different physics for the various different physics systems, we can box it up and dyn that. I think that makes the most sense. So let's convert our physics system into here. So we're going to do physics. We're going to have a mod.rs. We're going to move the physics system inside of here. Okay, so pub mod. So then we're going to have all the different physics. So we're going to have the dropping items physics. So what are those called? I don't want to call them like bombs or something. I want to call them like items, like chat items. Chat items, like physics. Let's go ahead and change you. So rename you to, I guess like drop items, item physics. Item physics. Okay, so pub mod item physics. Let's go ahead and also in our library, we're just gonna mod physics. You're gonna be upset with us, but that's okay for right now. Let's also create a trait for this. So we're gonna have a pub trait, and this is gonna be our physics system. And what do physics have in common with each other? Well, we know that they have a new, but those might be subtly different from each other. We know they have an update. Actually, if we take a look at it here, a new. Yeah, okay, let's just do that that they have an update. That's all. That will free us up to like be able to change what the struct looks like a lot more. So let's go ahead. A physics system has a function update that takes a mutable reference to self. And what else does it take in? It takes in a location, which is a rectangle, and the screen height for right now. So okay, so it takes in a location, which is a mutable reference to a rect, and we also take in a screen height. We're gonna need to make this the screen size, because for the player we want to make sure that I can't like go outside the screen bounds. So this needs to be the screen size, which is gonna be a tuple of F32 and F32. And I don't think we need to return anything. So that's going to be our trait. Then inside of item physics, let's go ahead and update this to sort of figure out what we care about here. This is going to be item physics. It has a velocity. It has an if it's affected by gravity. So, well, yeah, okay, we need this. Implement item physics. Okay, we create new and return an item physics. And this is all fine. Now, we happen to know that item physics are all going to be affected by gravity to begin with. So I don't need to take this in anymore. Affected by gravity is just going to be true by default. This update is going to be removed from here. So I can cut that out. And we're not going to have a handle input at all. So we're going to use player input. We don't need that, but we do need that trait. So it's going to be super physics system. So implement the physics system for item physics. Put in this function. It doesn't need to be public. It's public by default. Mute self, and then here's all this stuff. You're going to be a tuple of F32 and F32. Chantilly redeemed change music station. We go ahead and update that. We're on chill right now. Let's go to, let's try upbeat. I haven't tried that before. Oh, EDM, please? Okay, we could do EDM. EDM. Offset, let's see. So I think you need to set offset to mirror flip. Offset being the amount in the direction you want to go. Oh, interesting. Okay. We need to chop it up for other reasons too. But when we get to that, we could play around with that to sort of see how that's going to work. All right, back to this. We fall down, so self-location, so self.height.1 for the Y going down. Minus, okay, screen height, .1. All right, this will work for us. Let's come back to the main library. So this is going to be use physics. We're both going to need the trait physics system, but also item physics. Item physics? Wait, can I, in this mod, let's, oh wait, hub use. So forward that on down, so then you can just be item physics. Okay, so we have those down, coming down to you. Fire sprite. Draw system, flame size do that. Where's our, oh, physics system? None, so that's fine. Right, so this is going to be interesting. So the physics system that a game object holds is now going to have to be an option box dyn. So we don't have a physics system anymore. We do. Dyn physics system. Like that. So that works. Let's see. We're gonna have to take in. We're probably gonna want to take in an option physics system. We can box it up. No, we probably want to take in the box here. Everything else should pretty much just like come straight on through. For update here, we want this to be the screen size. And you can be an F32, and we'll turn you into a screen size. And you'd be the same there. All right, so you're all fine here. Let's head back to our main library. We have no physics system here, so we're fine. Create the player, when we create a new physics system for us. Stacking, good morning, hello. We don't have a player physics system, so let's go ahead and hold off for just a second with our player. But we do have this. Where's our method to create? Oh, we just create the other fire right in here and handle command. Yeah, this needs to be a different function since we're creating a fire like literally twice. Okay, so physics system, we want, okay, so new. So this can't, we don't want to create a new physics system now. We want to create a new item physics. And we're bringing in item physics. So we want item physics new. We don't need to pass in true. It's just got default by itself. That gives us the physics system for it. And then we're gonna box it up. So box new, like that. All right, that should work exactly. Let's see, mismatch types. Oh, we need to pass in, so here's the screen height. Let's go ahead and grab the screen size out of here. And threw this in here. Screen size. All right, that makes that happy. No errors. Let's see if this still works. All right, that's still showing. If we do a drop. Yeah, everything's still working exactly. That needs to change. We can figure that out pretty easily. See, where are we creating this? Let's create our let scale equals 2.0. What is that ugly yellow blob thing? That's fire. What, you couldn't tell? It's a flame. So here's our scale for that. And then when we do our width, we want to multiply by the scale. So times scale times the scale. So here, let's take a look at it again. So now if we drop them, and we can use like fire and then the column. Oh, I need to update this so it doesn't have a dash anymore. So it's like 5, and that will drop it in 5 there. It'll drop down to the ground, and it'll just sort of hang out there for 5 or so seconds before disappearing. It's supposed to be like a fire with a little bit of like the light source around it. With the idea being like that maybe is like the heat area around where like I'm not allowed to touch it. We can find better. I could find maybe better assets for that later, but for right now, that's what I've got. Okay, so basically we can now drop these down, and they get deleted and removed from memory as soon as they die after 5-10 seconds or so. So there's that. We want the player next. We need a player physics now. So inside of physics, let's go ahead and create a new file. Player physics, rs. And in this mod, we're also going to just mod player physics. All right, so pub.struct player physics. What do we really care about this? We do need a velocity, which let's just go ahead and make this a 0.2. Holding F32. We need affected by gravity, which is going to be a Boolean. We're going to need like the jumping, and we're going to need other things like moving. Let's go ahead and for right now, let's see. Let's see, velocity affected by gravity. I think for right now, this should be good. So impl player physics. And that's going to give us, we're going to have new, hub function new. We're not going to take anything in, but we're going to turn a player physics. And let's just go ahead and say that velocity is 0.2 new 0, 0, 0. And affected by gravity is true. All right. Bear, you figured out how to flip. So when you do a scale, vector2 scalar times -1 scalar, it is mirroring. Wait a second. So if you just scale it? You scale it by a negative number? And that flips it? That's interesting. You scaled on the negative x, okay. Yeah, because it goes the other direction technically. It scales all the way around, but because it's a 2D object, it flips like that. And then oh, that's pretty cool. I like that. All right, so we have a brand new player physics, but this obviously won't work unless we also bring in the trait. So let's use super physics system. For player physics. And we're going to need the update. We're going to take in the location of the player, which means we also need to bring in that rect. and the screen size. Okay, so that's gonna be fine. I should know this. You did exactly the first time you were rendering an image. Oh yeah, I forgot about that. I was doing weird mirroring type stuff when I was like playing with right when I didn't think that the scale was a percentage, but when I thought it was just by a pixel amount. You want to have to set the offset as well, so it's just in the right place. And if there's squares, I think that helps. But yeah, that'll be interesting. The draw system should be able to. We should be able to work with that. You're working with square because lazy. I'm working with squares too. I think the player might not be a square. We'll have to play around with that. All right. So I don't forget that in here. Can mirror sprites by scale using a negative number from bear doodah. All right, back to this. Player physics. If we just want to use our velocity, so we're just gonna say self dot velocity. Oh right, it's self dot location dot x. So we have our gravity falling down. Self dot c. If we want gravity to now be passed in, which it sounds like we might, because we have item physics, which has its gravity here of like 0.3. I want everything to be consistent, so we want the trait to pass that in with to update. Where's it? Mod. Let's bring in gravity. Gravity force is an F32. So in item physics, that means we have to bring in gravity force, which is an F32. And that's the only change you need there. We need to change this now in the library when we're creating. No, not the library. This gets changed in the game object when we're running update here. It cares about the gravity force. If you do something along the lines of let drop params equal graphics drop param default dest self location offset, then scale. Graphics draw. You see entity system, are you implementing your own kind of ECS plus GGEZ? Not exactly. Also, good morning, Vrizix. I'm not like implementing a true ECS system. It's really just, and I'm not really using like a grid for this either. It's just more of, I think it's called the update pattern, where I'm storing all the game objects together, but because of that, they all have like the same looking update method, but then they can have their individual physics. So it's something that I learned in that game pattern programming patterns book. So it's not all the way to an ECS system, but it's like halfway there. All right, so you with update, we need to pass into you like whatever the gravity is. We could probably implement that here. So let's do const gravity force F32 equals 0.3. and pass that in here. And in here. Okay, so that makes you all happy, I believe. Only takes 2 arguments. Fine. Be that way. Right. The children need this. We just need to rip out the children. We're not using them. And this entire add child, that's gone too. That'll make things easier. We don't draw children either. All right. So we update this. Grab that out. And this is now the player physics. So then we're gonna have the gravity force, which is an F32. Okay, so that makes you happy. So the first thing we're gonna do is we're gonna run the gravity force. So that's gonna be self.velocity.y plus equals to the gravity force. You see entity system you're implementing. Oh, I already did that. Is there a fire all? No, I'm not going to implement a fire all. That's just like a kill me. Like there's no way for me to avoid that. Chantilly. Going for the kills. Now if I put in some kind of blockers, then maybe, but let's see. Okay, so we apply gravity, then we want to change our location. So then our location dot y is plus equals to self dot velocity dot y. Okay. Then we want to hit the ground. Oh, we only want to do this. Hold on, I forgot. We'll only do this if we're affected by gravity. So if self dot affected by gravity, if that's true, then increment the gravity force. I'm gonna keep that down here. All right. If we hit the ground, so we want to check that. So if our location dot y, if that plus our height, so plus location dot height, if that's greater than the screen size dot 1 for the x, then we're clipping through the floor. So let's turn off gravity. Self dot affected by gravity equals false. Let's reset our horizontal movement. So self dot velocity dot y equals 0.0. And then let's also reset our location. So location dot y equals screen size dot 1 minus location dot height. Okay, so I think that will now allow us to like sort of fall down to the ground. So that should bring us to where we were before. We come back to the main library. Here's our player. Let's go ahead and re-add all of this code back in and bring the player back into the fold. There. Our player physics system can't be a player physics. This is going to be a player. Ooh, we need to re-export that. Am I doing that? This is going to be the player physics. So that way in the main library, I can use. Where's our physics? Player physics. Then in here, you will be player physics new. So we get our player physics system. This will then be a box new player physics system goes in there. And then no more errors. Let's try it out. Here we go. So we have our player now. Next thing I want to do is this is all like that refactor is all so that I can handle player input. I think that would kill me. A Raven Legend, good morning. Eight warnings. Yeah, I have a bunch of warnings. I'm doing pretty good. I was a little bit tired at the beginning, but finished my my tea, and that woke me right up. So let's go ahead and implement our player input here, so we can move left. So in player physics, in update, I want to check to see if I've got left going on. I'll fix those errors eventually. Most of them are like just not being used things. Okay, so does that mean I need context though? I think it does. I'm probably gonna need context. So let's use GGEZ input keyboard. Probably just want input for right now. And then also use GGEZ input keyboard key code. Those things. Those two things. All right, so here in update, I want so for my handle input, in regards to the game you're making, could you make the same game with Python and or JavaScript, or is it better with Rust? No, it's definitely something that could be made with Python and JavaScript. It's probably easiest with JavaScript because this is a Twitch chat game. I'm listening to Twitch chat. There is an amazing library on NPM called TMI that very easily listens to chat. I'm using something that's very similar to that in Rust that allows me to get chat messages and pass them into my game. So if I was not going to do this inside of Rust, I'd probably use JavaScript. That being said, there's nothing stopping you from using Python either. And of course, Java. You could use Java. Let's see. We want to check to see our input. So we want to say if input keyboard is key pressed. Right, so we need the context. So that means these updates, we're going to need to pass the context through. I don't think that's going to be too hard of a thing to do. And then the key code. So that's going to be the key code Let's do A to begin with. If we want to do that, then let's just store in like the left const left left move. Oh, move force, which is an F32. And we'll just set this to like 1.0 for right now. And so for left movement, it's going to be self.velocity.x minus equals to the move force. And that's pretty much it. So while we're holding this down, we increase our velocity by that amount. In regards to the game you're making, oh no, I already answered that. Let me go ahead and mark that as done. All right, so we need to pull in context. So input, also bring in context, and for this update, we need to pull in context, which is mute context. Of course, if I do this, the trait's going to be really unhappy. So let's go ahead and update this trait to pull in the context. Which also means the item physics needs to be updated here. Okay, so you're all happy there. In game object, we need to take in the context. And pass that into here. So that'll make you happy there. Then of course, in the main library, when we run update on this, we're gonna need to pass in the context. And no more errors. Let's go ahead and see if this works. I need have it telling me I'm moving to the left, but it's not actually moving to the left. There's this entire, we don't need that. Let's double check that in the player physics. Is this doing anything? Oh, self.velocity is .x. We're not doing anything with this. So let's do location.x plus equals self.velocity.x. That should move us around. There we go. We move to the left. And then if I want to move to the right, it's going to be the opposite. So we can only move in one direction at a time. So we can do an else if input keyboard is key pressed, context, key code. Let's do S. Velocity.x plus equals to the move force. So if I do that, do I make games for a living? No, I do not. I'm a web developer for a living. All right. So you may be thinking that I'm absolutely insane for using S instead of D. I actually have a different keyboard layout. So my D key is S. I could normally, like with most games, I have to like switch back to English, and then that would work. But This means I can play it without me doing this. All right, so I can now move left and right and try to avoid these things. I think next thing, let's go ahead and update our README here. Player can move left and right, but something that I want to do here is player slows down to a halt when I'm not holding like the move key down. I'm not holding a move key down. All right, so that will be coming up in the future stream. So I'm gonna go ahead and see. All of these are saved. There's nothing not saved here. Let's go ahead and open up, get cracking. I'm doing these streams every single weekday morning, starting at 7 a.m. Mountain Time for about, I don't know, hour and a half or so. It's there. Player can move left and right. And I'll go ahead and push those on up. Will I add player acceleration? I don't know if I'm gonna need a player acceleration. We'll just sort of see how it feels to me, especially since I'm the one who's going to be using the player to avoid all of you. That'll be sort of like something I figure out. It'll sort of have acceleration on its own because I'm adding to velocity. So that's because it's additive. It's just like slowly increasing the speed as I'm holding the keys down. And when I'm adding some kind of force to stop myself from moving, that'll also like slow myself down. So it should feel decently smooth. I have all this code. It's open source and available. I didn't check the bot. It died. I need to go and restart that. Okay, well, let me go find that. You're here. Here it is. Get the streamer game. All right, there he goes. Feel free to sort of play around with that. It's all the code is there. It should work just fine on your own system. You do need environment variables to work with the Twitch chat though to make that run. Yeah, and I guess like it needs to be part of like the workspace too. So it's a little bit hard to like get it going right now. And I don't have the binaries being put up in there. I think that's something we'll do at the very end. But this is also something I'm planning to like just run only on my own system, unless like other streamers want, reach out and ask me to like, make a build for them. Then I might consider like making this more something that anybody can just get and download and play. All right. With all of that being done, I'm going to go ahead and switch over to the ending scene. And let's see. Mr. Halsey is streaming right now. Let me go ahead and load up his stream. I'm thinking we can do a quick raid. Let me set that up. Do a raid. Mr. Halsey, start that. Turn off the music. That way I can hear him when we raid, and I can then chat all that stuff. Okay, everybody, let's have a great day, and I'll see you all next time, which should be tomorrow morning at around 7 a.m. Mountain Time. See you then, and bye.